Alright guys, so in this video we are going to be finding zeros, x-intercepts, roots, solutions to quadratic functions. So again, what does that all mean? Well, basically all of those words that I just listed for you, like I've said before, those are all of different ways to say that we're basically finding x-intercepts of our parabola, okay? So here we go. The first way I'm going to show you is quadratic formula, and then next I'll show you graphing. So here we go. What if they gave us a function that was 2x squared plus 3x minus 20 set equal to 0. Keep in mind, every time that you want to use the quadratic formula, okay guys, you're basically wanting to make sure that it's in this form here. ax squared plus bx plus c equals 0. Okay, so again, you want to be in standard form, which is right here. ax squared plus bx plus c is equal to 0. And again, using the quadratic formula, I'm going to put the quadratic formula right here. X is equal to negative b plus minus the square root b squared minus 4ac all divided by 2a. So you get those a, b, and c values from just the coefficients that are in front of those x's and that c number that's in the back. So do not say to me, if I say what is a equal to, some people like to say, oh, it's 5x squared. No, a is just 5, okay? Just the number or coefficient that's preceding in front of the variable. All right, so here a is 2, b is equal to positive 3, and c is equal to negative 20. All right, so we're going to respectively plug in the values into the formula. X is equal to negative, the b value is 3, plus minus the square root. B squared is 3 squared minus 4, a is 2, c is negative 20, close it. Again, I'm using parentheses just to show the substitution, and then 2 times a, which is 2. All right, in the next step, what I like to do, in the other problems, guys, I'm not going to do the parentheses. So x is equal to negative 3, because again, a negative 1 times 3 is negative 3, plus minus, I know 3 squared is 9, and again, I can't stress enough, keep that subtraction symbol in the formula right after you square your b term. And then again, what I like to do is, this is the part I would plug into the calculator. So I'm going to say 4 times 8, okay, I'm sorry, 4 times 2, which I know is 8. 4 times 2 is 8. 8 times negative 20 is negative 160. All divided by 2 times 2 is 4. So this minus minus becomes a plus plus. And then I have negative 3 plus minus the square root of 169, all divided by 4. X is equal to negative 3 plus minus. Again, there's nothing to do on the bottom with the 4. And I know that the square root of 169 is 13. Okay, you can take your time and plug that in the calculator if you would like, or pause the video. But here are your two solutions. Negative 3 plus 13 divided by 4. Your other x-intercept, or 0, is at negative 3 minus 13 over 4. Now this one, to me, is real straightforward, because negative 3 minus 13 is negative 16 divided by 4. So one of my x-intercepts is at negative 4, 0. This one is 10 over 4, which I'm dividing them both by 2, which is 5 halves. So my other x-intercept is at positive 2.5, 0. So there are your two x-intercepts. Be very careful. I enjoy using the quadratic formula, very much so, just because, again, you just get your answers. Decimal, whole number, doesn't matter, okay? Now, I'm going to do another one on this side, just so I can just keep looking at my formula. So here's another one. Let's do 3x squared minus 54x plus 241, okay? And we've set that equal to 0. Okay, I'm also going to show you one when it's not perfectly set equal to 0. And the quadratic formula, again, is really good when something is not factorable, because I'm going to show how to do factoring. But if a problem is not factorable by default, go to quadratic formula, okay? And then also you could do graphing, but I like quadratic formula. Okay, so for this one, your A is 3, your B is equal to negative 54, your C is equal to positive 241. And so now what I'm going to do is carefully plug into this formula right here. I'm not going to use parentheses this time. So I have x is equal to negative b. Now keep in mind this one's a little bit different because I have negative, and then the b is a negative 54. So I'm going to put a negative 54 here. Minus minus becomes plus plus, and then I have plus minus the square root. Then I have to do b squared. Well, I have negative 54. I have to square that. It's going to be a big number. Minus 4. My A is 3, and because I'm running out of room, I'm going to delete this stuff on this side. Everybody's deciding to come in here while I'm filming. All right, so that should be enough room. Okay, now for this one, again, my C value is a positive 241, so I'm going to plug in my 241, close it, and then square. This one I decided to use parentheses because, let's just be honest, the fact that the numbers are so large, I just want to be careful and show y'all the signs, okay? So here we go, second step. X is equal to, this is a positive 54 plus minus the square root. Now I'm going to grab my calculator, and negative 54 squared is basically negative 54 times negative 54. It's a huge number, okay? And it's positive. So let me clear this out and go to second quit to go back to the calculator. So again, I have negative 54, close it, and then I'm going to square. So this is going to be some large number. It's going to be 2,916. So in here, okay, so, and I think this is too thin, so let me just, I don't know why it's like that, but make it thicker. Okay, hopefully this is better. Yeah, so again, this is a 54. Let me make it even more thicker than that. Jeez. Okay, 54 plus minus the square root. And I just told you guys that negative 54 times negative 54 is 2,900. I think it was 61. Let me go back to my calculator. Yeah, no, it was 2,916. 16. Okay. 2,916 minus, now remember, put the subtraction symbol. You need to go multiply all of this together. So 4 times 3 is 12, and then 12 times 241. So let's go do that on the calculator real quick. So we got 12 times 241 is 2,892, and that's good because, of course, you know, it's going to give me a positive number. So 2892, so right here, let's put 2,892. All divided by 6 right here. All right, so here we go. 54 plus minus the square root, and then there's a 6 down here. So we're going to go subtract that 2,916 minus the 2892. 2,916 minus, for a moment, so I'm here, x is equal to 54 plus minus, I'm going to get you a decimal number, but can we talk about that? Remember how we talked about simplifying radicals? Like if I have the square root of 24, I can break that down to 6 times 4, 2 times 2, break the 6 down to 3 times 2, and remember we said that the pairs, one pair will come out, and then the singles end up staying in, right? So basically I'm telling you this is the same as 2 root of 6, right? So 2 root of 6 if you wanted to simplify this. Now again, I'm just going to go to the calculator and I'm just going to put the square root of 24. So second, hit that x squared button, put 24, and there's your 4.8989. But also if you were to do 2 times the square root of 6, notice you're going to get the same answer. But again, this is just in the reduced or simplified form. It doesn't matter, they're the same number. So I'm going to just say it's like 4.9. Okay, 4.9. So I go back to here and I say, hey, This right here, I'm going to delete for a second. This is 4.9. So I'm going to replace that with 4.9. And here are your two solutions. 54 plus 4.9 divided by 6. And the other one is 54 minus 4.9 divided by 6. There's a decimal right here. 4.9 divided by 6. All right, so what are our two answers? Our two x-intercepts. So I'm going to do, give me 1 second. All right, so let's do 54 plus 4.9, right? And I believe it was we divide by 6. Yeah, I think we divide by 6. So one of your x-intercepts is at 9.8, 0. The other one is 54 minus 4.9. Excuse me. 54. Oh no, 54 minus 4.9. I missed the decimal. Then divide by 6. 8.18. Okay, so one is at 9.8, one's at 8.1 or 8.2. All right, there we go. Okay, those are your two x-intercepts here and here. All right, so let's just do one more. Let's do one more with quadratic formula. So I'm going to clear this out and let's see. So what if they gave us something like let's do 4b squared plus 8b plus 7 is equal to 4. Okay, now remember, you definitely want to get it in standard form, so it has to be set equal to 0. So that 4 needs to do inverse operation. So we're going to subtract 4. What I do to one side, do to the other. There's a 0 here now. 7 minus 4 is 3. And then I'm just going to drop down my 8b and the 4b squared. My a is 4. My b is equal to positive 8. My c is equal to 3. And then here is the quadratic formula once more. B squared minus 4ac divided by 2a. All right, so very carefully we're plugging it in. Negative, and then our b value is a 8, so it becomes a negative 8 plus minus the square root. And I already know that 8 squared is 64 minus 4. The a is 4. The c is 3. All divided by, and then I know 2 times a is 2 times 4, so this is an 8 on the bottom. Real easy. Now in this step, let's do x is equal to negative 8 plus minus 64 minus, and then again, I can't stress you enough, multiply out the 4ac part, so 16 times 3 is 48, all divided by 8. And again, you have negative 8 plus minus, and then 64 minus 48. Let's do that in the calculator. Let me clear this out. 64 minus 48 is a positive 16, and then we know the square root of 16 is 4, right guys? So again, we had got the square root of 16 right here. I'm just going to write it right here so you know where I got it from. Square root of 16, but this is a 4. Square root of 16 is 4 divided by 8. All right, here's your two x-intercepts. Negative 8 plus 4 over 8. And then negative 8 minus 4 over 8. Again, if you still have not understood what I've said about, how I'm getting these different solutions, is because, again, the first thing I do is I say, hey, negative 8 plus this value over 8, and then I'm doing negative 8 minus, and then this value over 8, okay? All right, so what is our final solution? Well, this is negative 4 over 8, which is negative 1/2. So one of my x-intercepts is at negative 0.5, 0. And then this is negative 12 over 8, which negative 12 over 8, if I divide those both by 4 as their greatest factor, I get negative 3 over 2. Again, I divided this by 4, got negative 3, divided this by 4, and got 2. This is negative 1.5. So one x-intercept is at negative 1.5 comma 0, and the other one is at negative 0.5. All right, now I'm going to do one more, and then that's enough for quadratic formula. I'm going to show y'all this one. This is one that I did with the in-person group, and it didn't go too great, but I don't want anyone to freak out. Here we go. So what if they gave you something like k squared minus 31 minus 2k is equal to negative 6 minus 3k squared minus 2k. So as you can see, you definitely want to get this in standard form and set equal to 0. So all of these terms that are over here on the right side of the equal sign, you need to do inverse operation. So watch as I do this in one step. What was a minus 6, I need to put a plus 6. Well, I need to put a plus 6 over here, and that's its like term. This negative 3k squared needs to change to a plus 3k squared. It needs to go right here under the k squared term. And then this minus 2k needs to become a plus 2k, and then it also needs to go under the k term. So again, this is 0. This cancels out for 0. This cancels out for 0. So on the right side, now we have a 0. Now we come over here from left to right and we say, hey, there's a 1 here. Now we added a 3. This is a 4k squared. And then I like my k terms to be next, right? But guess what? This is 0. So now negative 31 plus 6 is a minus 25. So as you can see here, you canceled out and there's no k term. Now we can actually solve this in two ways. We can use the quadratic formula, or we can actually take the squared because there's no other additional k. So the reason why you can't take the square for the other ones that are in standard form is because you have a k squared and a k. But this one just has a k squared, so we could solve for k. So I'm going to, for a moment, solve this with taking the square, and then, guys, I'll turn around and use the quadratic formula, and we'll see if we get the same answer. So I'm going to add 25, add 25. So I have 4k squared is equal to 25. Again, I'm just trying to solve for k, right? But I have a k squared. So 4 divided by 4 over here is, 4 divided by 4 is 1. Try to do something super quick. I was doing it before, and I guess I can't do it now. What's the deal? Weird. There, that's what I was trying to do. Zoom, get some more room. So 4 divided by 4 is 1. And this is just k squared equals. Now 25 divided by 4, I'm just going to do some scratch work. Well, I know that this 4 goes into 25 6 times for 24, leaves a remainder of 1. So see, this is 6.25. Where did I get that from? Because it was 6 and 1/4. So 6 and 1/4 is the same as 6.25. Okay, now see how I have k squared? What's the opposite of a square? A square root. So I'm going to take the square root of this side. I'm also going to take the square root of this side. The square and square root will cancel out. So now I just have a k. But I have plus minus the square root of 6.25. So this is where I'm going to go to the calculator and get that answer. So if I go to the calculator and I say second, hit that x squared button. There's the square root. What's the square root of 6.25? The answer is 2.5. Okay, so the solution to this is there is a positive, everybody look at that plus sign, positive 2.5 comma 0 is one x-intercept. Then there is a negative 2.5 comma 0. All right, those are your two x-intercepts. Okay. Now I'm going to go back again, like I said, and I'm going to solve this now with the quadratic formula. So let's go back, and what we're saying is here is our cleaned up quadratic function set equal to 0. That means a is equal to 4. There is no b term. It's 0. C is negative 25. So if I plug it in the formula, x is equal to negative b, negative 0. Don't freak out. It's just a 0. Okay, so there's just a 0 right here. Don't worry about the negative 0. Just a 0. Plus minus the square root. B squared. What's our b? 0. So 0 squared is nothing. 0 squared. That's just 0. Minus 4, our a is 4, our c is negative 25. But you have to stay true to the formula. So put the 0. And then 2 times a is 8. So x is equal to, so there's nothing for me to write here, just my plus minus square root. Do y'all see that? And any other time we would put our b squared value, but since it's 0, don't put anything there, just put the subtraction. And now I'm going to stay true to multiplying my 4ac out. Y'all see that? So 4 times 4 is 16. The question is, what is 16 times negative 25? So I'll go here, and I'm going to say negative 16 times, was it negative? No, I'm so sorry. Just say 16. Yeah, times negative 25. See what you'll get here? You'll get a negative 400. And if I go back here, I already had that minus from the subtraction. When I multiplied 4 times 4, which is 16 times negative 25, I got negative 400. Minus minus becomes plus plus. I know that part's a little tricky. So what we have here is x is equal to plus minus the square root of 400 over 8. Now I already know, knowing our perfect squares, the square root of 400 is 20. So here are your two solutions. You have a positive 20 over 8 and a negative 20 over 8 for your x-intercepts. So let's check those out in the calculator. So what is 20 divided by 8? 20 divided by 8 is, what do you know? 2.5. And the negative 20 divided by 8 is the negative, messed up, sorry, negative 20 divided by 8, you're going to get negative 2.5. So there's the same answer of what we got when we took the square, guys, is we have, again, those same solutions of 2.5, comma 0, negative 2.5, comma 0. Perfect. All right, so I hope that you understand quadratic formula a lot better now. Do well on the day of the test. All right, so let's shift gears now. And again, one method I just showed you, I think I literally did 4 or 6 examples of quadratic formula, one of taking the square. Let's talk about graphing. Let's talk about graphing. So another way that you can get your x-intercepts or zeros or roots or solutions for a quadratic is by just picking up the calculator, right? So when you're graphing, remember there is a button like that that says y equals on the calculator. And this is where you begin to write in, your equation to graph. So I'm going to do 3 of these super quick. So one, let's do where it says, I'm just going to show the function notation again. F of x is equal to x squared minus 12x plus 44. Remember from unit 2 that this right here, that f of x is basically a y. So I'm going to replace this with a y equals, and again, this is a function. So we can graph it in the calculator. Because again, that f of x is saying, hey, when you plug the values of x in to the function, right, you will get out an output. And so that's why as you plug in values of x into here, which is the function, you're getting out this value, which is a y. Okay, hope it makes sense. So let's graph this one, and then another one I want you to write on your paper. F of x equals negative 1/4 x squared plus 7. Again, how do we write that again? Replace the f of x with a y. We're going to also graph this one and find our x-intercepts. We're also going to use the calculator to find the vertex as well. And then the last one I want us to do, write all 3 of these down. Y is equal to, I like this one. Well, it doesn't say a y. Let me be clear to what's on my paper. It had this, 2x squared minus 36 equal to x. So what do we do, guys? Move the x over. So we're going to subtract x. There's nothing to combine here. Okay, so now we're also going to graph, let me move up a little bit, we're also going to graph this one. So 2x squared minus x minus 36, and then if we set it equal to 0, not a big deal, but what is this again? This is a y. So just put this into the y. All right, here we go. So first things first, like I said before, is you go to that button, that's your y equal, and then you plug that in, right, with respect to x. The next thing you'll do after that is you go to second calc. I'm just outlining the steps. You go to second calc or second trace, and then from there you hit option number 2, which is called zeros of the function, which are x-intercepts. And then you do the thing that says left bound. You scroll to the left, then it'll ask you right bound. Scroll to the right of the parabola and you use those side arrows, left and right. Once you hit enter on the left side and the right side, then the next thing is you want to guess. And it will spit, and you try to get as close to the x-axis as you can, and it will give you the answer to your x-intercept. Then you have to do it again for the other x-intercept, right? So you'll get it on one side, get it on the other. All right, so let's do it real quick. So with the calculator, clear out this. I'm gonna hit that y equal button. And so right here, let's do our x squared minus 12x plus 44. Hit graph. Now, a couple of errors that you can tend to get, right, we've seen is, check your window, make sure it says -10, +10, 1, -10, +10, 1, 1, and then make sure that should fix it. If there's ever an error you get where it talks about some dimensions are off or stat something, hit second and then hit the y equal button. Make sure that your stat plots are all turned off, except for the last one. That one doesn't hurt anything, but make sure these major ones here, 1, 2, 3, 4, are turned off. All right, so let's go back to the graph. And again, we're going to find the zeros or x-intercepts. So go to second trace or second calc. Option number 2 are zeros. Left bound, we're on the left side. Hit enter. Go to the right side, right there. Hit enter. And then it says, hey, guess. Well, here's the interesting thing. We're done, people, because notice how this parabola does not go down below the x-axis. So guess what? We have no x-intercepts on this problem. We have no x-intercepts, so we say it is imaginary. The x-intercepts are imaginary because they're not there, okay? And it does not, again, intersect at all anywhere with the x-axis. All right, but one thing we could do on this one, let me hit clear, is let's go get if it has the vertex. So because it's facing upward, our a was equal to +1. We do have a minimum because it's facing upward. So let's figure out the coordinate of the vertex. So I'm still going to hit second trace. I'm going to go to the option that says minimum, option 3, hit enter. And there I messed up a little bit, double clicking enter, but there's right bound. Here's left bound, enter. And to guess where the vertex is as a minimum, I'm just going to get close to the bottom as I can and then hit enter. And it says, check your right bound, left bound. Remember, this is an error that we get, so let's just start again. Second quit. Let me go back to graph. It didn't like something I did. So second trace. I'm going to go to the minimum, 3. It probably didn't like that I didn't start on the left side. So I'm going to go to the left side, hit enter. Go to the right side, hit enter. And then again, I'm going to just start to go as close to the vertex as I can. That looks like the minimum. Hit enter. And there it gave it to me. So at 6,8, 6,8, that is the vertex. Also, if they say, hey, but what is the true minimum of this? They want the y value. So you'll say the minimum on this graph is 8. With respect to outputs, right, the y's. If you talk about the domain of this function, you would say the x values are all real numbers, -infinity to +infinity. So that means when you look at from left to right, see how the x's start here and they're going here, but this is infinite, so they're eventually going over to negative direction. Here they're just going over also to the right, to the positive x values. So there's no limits. So we say infinity, all real numbers for the domain. However, for the range, we notice that the bottom, the minimum value is an 8, and all my y values are what? Greater than 8. There's nothing happening in negative values for y. So the range is going to be y is greater than or equal to 8. All right, so that's that. Second quit. All right, let's do it again. Didn't mean to do it like that. It went to mode. Second quit. All right. So now let's go to the y equal again. Clear this out. And let's do the one that was a -1/4 x squared. Squared. I think it was a plus 7. So the cool thing with this one, hit graph, is going to be, notice it's going to face downward because our a value is negative. So as you see here, it looks like very slightly it does intersect with the x-axis. You see that? So there are some x-intercepts compared to the last one. All right, so now what we'll do is, again, second trace. Let's find the zeros, option 2. Left bound, so I'm going to come to the left side with my side arrow. That's pretty left. Enter. Go to the right side. Hit enter. And then I'm going to just guess as close to the x-axis as I can get or touch. Hit enter. And so as you can see right there, 5.3 comma 0 is one x-intercept. Then after that, let's get the other side. Hit clear. Second trace. Option 2, we're trying to get the one now on the left side. So left bound. Hit enter. Right bound of the parabola. Hit enter. And my guess now on the left side is about right there. Okay, hit enter. There's my guess. And as you can see, there's a negative 5.3 comma 0. And that makes sense because, again, we have symmetry. So our two x-intercepts are at negative 5.3 comma 0 and positive 5.3 comma 0. Now also from this, let's get the vertex or the maximum because it's facing downward. So I'm going to clear out again, hit second trace, and I'm going to go to maximum, option 4, hit enter. Whoops, it's going to give me an error. Let me hit clear again. Okay, option 4, left bound. Always start on the left. Left, enter. Right side or right bound of the parabola, enter. And my guess for the maximum is to get as close to the top as possible. That's my guess, enter. So as you can see, your maximum is at, again, this is a really, really small number, guys, for x. This is negative 0.00001455. Because you see this scientific notation, e to the negative 6. So I'm just telling you it's a really tiny number, comma 7. All right, guys. So I hope that makes sense for graphing. I hope quadratic formula makes sense. For the sake of the video, it's already at 30 minutes. I guess let me do one more graphing and I'll cut it there because I still need to show you factoring. But what was the other problem I need to graph super quick? Right here. Oops, where'd it go? Yeah, I need to do this 2x squared minus x minus 36. Okay, so again, y equal, let me clear this out, 2x squared minus x. I think it was minus 36. Yeah. All right, let's graph this one. It's facing upward. There it is. And again, we're getting the zeros, and I'll also show you the vertex. Second trace, option 2, left bound, right bound, anywhere you want, enter. And my guess is to get as close to the x-axis and above it as I can. Where can I do the down arrow? No, I can't do the down arrow. You see that? So, I'm gonna just stay right here. That's as close as it'll let me get. Sorry about that. Enter. It still jumps down and gives you the answer. So the x-intercept on the right side is 4.5 comma 0. All right, hit clear, do it again. Second trace, option 2, left bound, right bound on the parabola. My guess on this side, oops, that's just, I know I'm a little below it, but for negative 4 comma 0. So one is 4.5 positive, 4.5 positive comma 0, and this one on the other side is negative 4 comma 0, right? And again, what is the minimum? So you'll hit clear, second trace, option 3, and I got to do the same thing, left bound, right bound, and then my guess for the vertex, about right there, and there's the answer. The minimum is at 0.25, comma, 36.125. Okay guys, so I'm going to stop the video here. Hopefully this was helpful. You understand the quadratic formula better. You understand also how to use a calculator better. All right.